In this video, we want to confirm the following statement of equality. This is an exercise in trigonometry, a little bit of logarithms from algebra, and it's actually related to calculus also, because the answer in the left is the answer that I got for one video in which I was evaluating a integral. And what I have on the right is also an answer that was possible, depending on whether you wanted to simplify it using logarithms. But here we just treat it as a simple identity, just like trigonometry. So we'll start with one side and show that it's equal to the other side. So I'll simply take, in this case, the left side, minus the natural log, cosecant of x, plus cotangent of x, and say, okay, this is the same thing. There's a property in logs that tells you if you have a coefficient, in this case a -1, we can take that coefficient and make it an exponent. So by that property, I can rewrite this expression this way. So I bring that -1 coefficient to an exponent. So I got that. And then I can rewrite this as using properties of negative exponents. This will be the natural log of 1 over. This will be cosecant of x. And this will be cotangent. And then I just put the absolute values out here. I could bring the exponent inside and put this in parentheses and then just leave everything else inside the absolute values. I just leave it like that. So that's one step right there. Okay, just to save some time here, my next step would be this. So still working from inside the absolute value here. I'm going to multiply here by cosecant of x minus cotangent of x. Again, all of this is inside the absolute values. And I can do that as long as I multiply the numerator by the same thing. So I put parentheses here. This will be cosecant of x minus cotangent. Oh, parentheses here. So this is then equal to ln, natural log here. And again, everything's inside the absolute values for now. So cosecant of x minus cotangent of x times 1 will just give me that. I've got cosecant of x minus cotangent of x. Now in the denominator, I have cosecant of x plus cotangent of x times cosecant of x minus cotangent of x. So it's like multiplying the difference in the sum of the same two terms. So a plus b times a minus b is a squared minus b squared. So here in the denominator, then this would just be cosecant squared of x minus cotangent squared of x is equal to. So again, some trigonometry using one of the basic identities. We know that 1 plus cotangent squared of any angle, in this case we're using x, should equal to the cosecant squared of that same angle. Or I should say, if I bring the cotangent squared to the other side, or adding negative cotangent squared to both sides, I get cosecant squared x minus cotangent squared x. That's equal to 1. So getting back to this step right here, I got cosecant of x minus cotangent of x over, and this is cosecant squared x minus cotangent squared x. Well, that's 1. So I simply replace this in the denominator by 1. And this actually gives me ln, or natural log of absolute cosecant squared minus cotangent squared of x, because that's divided by 1. 1 into cosecant x, and this of course should be just cosecant x cotangent x, absolute value, natural log of absolute value of cosecant of x minus cotangent of x, and that of course is what we wanted to get, because 1 into cosecant x minus cotangent x is cosecant x minus cotangent x, and that's absolute value, so this is what we wanted. And that confirms this equality. Thanks for watching. We'll see you next time.